Ideally, when you hear people talk about, what is safety critical? What is safety critical? What is major accident hazard? From the word safety critical, I'm a student of English, and I always tell myself, as a chemical engineer, if you want to define anything, it's just to first of all understand the name. Safety critical, that means it is critical to safety. And the most important thing is that anything that is critical to safety is others critical to some other receptor. That is hazard with regards to health, environment, with regards to reputation, with regard to regulatory. It can have an asset impact and financial impact. So these definitions you are seeing here come from the UK HSC and part of CCPS also, and from the Australian standard. So an SCE is actually defined as part of an installation, structure, plant equipment system, including computer or any part of the failure, which the failure could cause or contribute substantially to the release of hazard with major risks, or purpose of which it is to provide a barrier to prevent or limit the event of major accident. So what that tells you is that when something is safety critical, that means the failure, whether it's the failure of a pressure vessel or the failure of a rotating equipment like a compressor, or the failure of a piping system which contains toxic chemical or contain gases or hydrocarbon liquids, when that fails and it causes anything major or anything catastrophic, that means that thing is safety critical. So it mustn't fail. If it fails, that means a lot of bad things can happen. And in the major accident hazard, each barrier type is presented by one or more SCEs and is designed to stop or minimize the effect of hazard. So you ask yourself the next question: what is the major accident hazard? The UK HSC defines major accident hazard as a hazard that has the potential to cause harm from the occurrence of a single, unexpected, unplanned, acute explosion, release, or event. And the purpose of the major accident hazard itself is the release of unwanted events. And when we talk about unwanted event, that means it can be event that can lead to fire, explosion, or major environmental impact. These are mostly events, not low events, but major, high, and catastrophic HSE event. And if you look at the history of process safety, even looking from in the 1950s up to today, we are still having those incidents. And that is why they are called major incidents. When they happen, they can kill a whole community, which is the issue of Seveso and also the Bhopal, India. So what is an SCE and MAH? I've defined what the MAH is and SCE. You can see what major accident is all about. This is more like the Flisbro disaster when it happened. And this is one of the hazards that happened, the other picture in a cyclohexane plant. And when this event happened, most of the time from the picture you can see there is the impact are massive and not a lot of people make it home at the end of the day. And that's why they are called major accident hazard. Now, when we talk about an SCE, I've already told you that the SCE is part of an installation that it mustn't fail, because if it fails, it can lead to catastrophic or major incident. SCE itself has been called different things by different school of thought in the industry. There are people that will call it safety critical elements. Some people will call it safety critical equipment. I don't bother myself trying to understand which school of thought is correct, but the only thing I will tell you, whatever you call it, it is safety critical. So there are three categories of SCEs in the industry. Some organizations will define it as two, some will define it as three. But today, I'm here to show you whether you define it as two or three, the three categories I have chosen today. Some of the SCEs, they are prescriptive based, some are function based, and the others are consequence based. When you talk of prescriptive based, some of the prescriptive based SCEs are prescribed by regulation. They are prescribed by standard. They can be as a result of the government policies of the day. But I have defined prescriptive based on inherent hazard or their function, regardless of the severity of the consequence for their failure. What this means is that regardless of the consequence of their failure, these have been prescribed in the industry or by organizations to be critical. Example of that from the picture you will see is pressure vessel. Anything more than 15 psi or greater than 1 bar, we definitely know that that is safety critical because it's categorized as a pressure vessel. The PSV, the pressure relief, the pressure valve, vessel, pressure valve and relief valve of vent systems, they are designed as safety critical based on their prescriptive nature. If you see things like SIS or safety instrumented function, combustion safeguard emergency devices, fire and gas detection system, HIP system, high integrity pressure protective systems, high energy rotating equipment, steam turbine, example, compressor, gas turbine. These things, from their nature, if they fail, they can actually lead to an unsafe days, which is always major catastrophic or high hazard effect. And that's why you can see from the picture today that anytime you see, you hear in the industry, somebody say, this is an SCE that is prescribed, always know that it is based on the fact that they are inherently hazardous. That means if they fail, it's going to be a big problem for the people on the plant, or it can actually cause an environmental pollution. The next one I want to talk about this morning is the one that is called the function-based SCE. From the word function, that means if you terminate their function, or if they fail to activate, or if they fail to deliver what they've been planned, what they have been designed to do, it will lead to a catastrophic or a major accident hazard. Example of this, you should have seen in the industry, is the deluge system, the dikes, the containment, the ventilation system, the explosion panel, emergency alarm, UPS, backup power, hazardous ventilation, electrical bonding, and the inerting system. I recently have a discussion with a VP of an organization, and he asked me, is the UPS actually safety critical? You don't want to, except you are a student of safety or you are an instrumentation engineer or electrical. If you look at the UPS very well, the UPS is one of the most underrated SCE we have in the industry. And that's why the functionality of the UPS is very important. The basic function of a UPS most of the time is to safely shut down the plant in the event that you have power failure. It gives you the time to take the plant to a safe state. So whenever you see a UPS on the plant, it is a very good thing to always ask the operator, do you really know the function of this UPS? And do you know when was the last time the ITPM was done on that UPS? And ITPM means inspection, testing, and preventative maintenance. The last one I want to talk about is the consequence-based SCE. This type of SCE, from the name, consequence, that is, if they fail, the consequence can be severe. And that is what leads to the unsafe days. Example of this will be the piping system, the pumps, whether it's rotating or whether it's static, the seals, the mechanical seals, the flexible hoses, the knockout drum, and the scrubbers. You know, again, a lot of people don't even know that the piping system is actually safety critical. That's why when you design, you have to design it right. When it's a carbon steel, it has to follow the ASME code or the ANSI code. And when it's a stainless steel, you also have to follow the code. And that's why if you see the piping system itself, take a time when you go to the plant and look at the piping system, especially whether it's hydrocarbon, whether it's chemical or petrochemical. Take a look and see what is that pipe rated for. What is the product in that pipe? And you will notice that these piping systems are actually under regulations that they must be adequately designed. You know the reason? The reason is that if they fail, the severity of the consequence can be really, really catastrophic. Do you know what your safety critical elements are? Or do you know what are your safety critical equipment? They properly designed? When last were they tested? Can you show me? Show and tell is one of the reasons why our industry can stay safer than yesterday.